Hi there. Today, I'm going to talk about the critical path method calculation, which is one of the understanding we need to have when it comes to our PMP or your CAPM examination. We are going to talk about a couple of examples, but I'll start with a very first, very simple diagram, network diagram, and then we'll move on to a more complicated one in the next videos. Now, imagine we are given this kind of a question, as in there are some activities that is defined. So for example, we talk about activity A, B, C, D, E, and F. Now, the way how we need to understand this is in your examination, usually they will not give you a realistic word for that because that might cause unnecessary confusion. But what you can do is imagine something like this. If you're talking about A, probably scrubbing the wall. B, probably plastering the wall. C, probably painting. Something of this sort, if you can imagine, you will have a realistic network diagram in place. Now, let's draw this diagram based on this question, and then we can explore further. The information that you saw in the earlier slide has been given in this network diagram. The interpretation is something like this. The project starts with activity A, and it is going to take 5 days to complete this activity. Activity B and activity C can start immediately after activity A. So if you look at it, the arrow from A is diverging, and we are able to see B and C over there. B takes 3 days, C takes 4 days. Activity D can only start after we finish B and C. That is why the two arrows are converging. Also, there is a dependency. Activity E can only start after C has completed. Activity F can start only after D and E has completed. After activity F is complete, the project comes to an end. So this is the interpretation. So if you look at it, within the box, box is considered to be the activity. Within the box, it's its name. On top center, we see the duration. Now, we need to say how soon you can start this activity and how soon we can finish this activity. That is what we are going to work out as part of your forward pass. Below the screen on the left-hand side, you're able to see the legend. So the name of the activity is in the middle, duration, top, middle, early start, left-hand side of the activity, top, early finish is right-hand side, top. In the activity, this is how it is going to be represented. Now look at this. Activity A is going to start on the 0th day. And since it takes 5 days, so we are simply going to do an addition. 0 plus 5, which is basically your early finish, which is 5. As I said earlier itself, B can start only after A has completed. So which means after the 5th, which is the same day, we are starting B. Same ways for C also, it can start after A. So the 5th day we are starting. Since B takes 3 days, we are adding 5 plus 3, which is 8. And for C, since it takes 4 days, 5 plus 4, which is 9 days. Since we know it starts on the 5th day and you need 4 days to complete it, we are going to do a simple addition to come up with the early finish. Now look at the activity D. We already said B and C must be complete before we start with D. B can finish only on the 8th, C can finish on the 9th. So eventually, we have to wait until the 9th in order to start the activity D. That is why D starts on the 9th. Whenever you have multiple activities converging, always look up for the highest value in the early finish and pick up that value as part of the early start for the successor activity. Since D takes 2 days, 9 plus 2 is 11. Now, for E, the dependency is only C, right? The predecessor is only C. So E starts on the 9th. Since it is 1 day, we can finish it on the 10th. Now D can finish on the 11th, E can finish on the 10th. So F can start only on the 11th. 11 plus 3, we have 14. So which means 14 days or months or weeks, whatever it is. We don't know what is the, at least I have not clearly defined it. So the 14 days, let's take it as days itself. 14 days is what you need in order to complete this project. Since we have already seen how soon you can start and how soon you can finish an activity, let's move on to the next one, which is how late you can start an activity and how late we can finish an activity. That is what we are working out with the help of backward pass. For the backward pass, we will be working out the late start and late finish. Below in the screen on the left-hand side, you're able to see the legends. Late start will be represented on the left-hand side bottom of the activity. Late finish will be represented below the activity on the right-hand side. Since the name specifies as backward pass, we are going to start from the last activity over here. So which means whatever we are able to see, maybe I'll just mark in the screen, whatever you're able to see here as the last activity, that will be taken directly as your late finish. So we know this activity finishes on the 4th, and we know it takes 3 days to complete it. So we can easily say how soon it can start, right? Or when it can probably start. So 14 minus 3, which is 11. Now we have this value 11 here. This is directly taken as your late finish. Watch out, early start and early finish is much straightforward to calculate. Late start and late finish, you need to be very careful. If not, we will be carried away with the early start, early finish values. So you need to always look below while you're working with this, yeah? So the 11 value is taken over here for activity D. Now we know it finishes on the 11th and it takes 2 days. So obviously 11 minus 2, we can work out 9 as the late start. Similar to that, for activity E, 11 minus 1, we are taking it as 10. Where do we get it? 11 minus 1. So we are talking about these two activities here, these two values over here to come up with the value 10. Now you look at C. Basically, when you talk about C, there is a dependency of D and E. D is starting on the 9th, E is starting on the 10th, which means by right, C should have completed at least on the 9th, only then D can start on the 9th. While working backwards, we will always be focusing on the minimum value of all the late start, whichever has a arrow. So just keep an eye on that alone. Again, 9 minus 5, which is 4, 9 minus 3, which is 6. Now, talking about this value here for A, as I said earlier, B starts on the 6th, C starts on the 5th. So if by right, A should have completed only on the 5th, only then C could have started on the 5th. This is how we work out our backward pass. Only when you practice this couple of times, you can get a clear picture about the forward and the backward pass. Forward usually is straightforward. Backward will be a little bit tricky. So practice can help a lot in understanding this. Once we have identified the early start and early finish, we are going to now work out the float. When we talk about the float, it is very simple. We are going to subtract these two values here. Late finish minus early finish, or late start minus early start. Either ways, you need to get the same value. If not, your calculation is wrong somewhere, which is very evident. So we are going to work out this calculation. So 5 minus 5, let me change the color just to make it more clear. So 5 minus 5 is 0, or 0 minus 0 is 0. Same ways, 9 minus 8 or 6 minus 5, we get 1. 9 minus 9 or 5 minus 5, we get 0. 11 minus 11, 0, or 9 minus 9. 11 minus 10 is 1. You should be getting the same here as well, 10 minus 9, which is 1. Imagine you're not getting the same value, which means your calculation is wrong somewhere. Validate your early start, early finish, and late start, late finish calculations. If your calculations are right, you will end up with the same value here. Same ways, here also we are getting 0. This is what we call it as a float. So float is for every single activity that we are talking about, right? So A has 0 float, B has got a 1-day float, D 0 float, C 0 float, E 1 day of float, F is 0 float. If you have to work out the critical path, if you follow through all the activities with 0 float, you will know which is the critical path here. So the critical path, which is the longest path in a network diagram, or the shortest or the minimum duration needed to complete the project, is called as a critical path. A, C, D, F is your critical path. When you look at it, this path will have a total of 14 days. Not only that, a minimum of 14 days is needed for us to complete this project. Any smaller than that, any shorter than that, you won't be able to finish the project. That's why it is called as the minimum duration needed to complete the project. Got it? So this is a very simple calculation. I'll come back with some more, a little bit more complicated calculations in the next few videos. Until then, if you have any questions, please put it up in the comment section and we'll take it up and we'll answer it in the subsequent videos. Thank you. See you in the next video. Until then, bye-bye.